My name is Paul Stevenson. I have been at OVH for 3 months now.
Let's go, roughly 3 months.
3 months
yeah,
now?
almost.
Previously, I was with vCloud Air. Neil and I were both VMware employees. I was there for 3.5 years. And due to the acquisition of OVH vCloud Air on May 8th of this year, we came over to the team. So we're actually really excited to talk with you. I am a staff SE and a field evangelist. And
I'm a technical product manager handling the private cloud stack. So that is vCloud Air as it exists today and as it will be evolving in the future, as well as the hosted private solution, which is all the VMware, fancy way of saying SDDC that's hosted in all of the OVH data centers in the US region.
So originally this presentation was titled Why Optimizing Layer 0 Matters. We changed the name to try and get a few more people. You can't tell, it's standing room only in here. But we'll still have that same context, but we're going to talk specifically about how we're delivering our technology stack. So here's our fancy OVH slide. So we're going to cover who is OVH. How many people in here knew about OVH, knows about OVH extensively? Okay.
Oh yeah, existing customers, potentially, internationally?
How many people are a customer of vCloud Air? Baylor? Okay, great.
All right.
Thanks, Eric. Then we're going to talk about the VMware Cloud layer by layer. And then we're going to take that technology and talk about the new use cases that this enables. We have the same ones that we've had for some time, and now there's some really interesting things that you can build on top of this stack. And then we'll have a few minutes for Q&A.
So, thank you for the clear. Yeah, the biggest question that we're hearing, especially here, is who's OVH? And we knew that coming in. OVH has a name, they have a history, we'll jump into that in a second, but that's primarily in Europe. So if we have mostly for VMworld US, our US customers, people curious in the US, you likely haven't heard of them before. Oh, OVH at the core, global hyperscale cloud leader, and that's going to sound a little weird at first. It's a hyperscale cloud leader that you haven't heard of before. So we're going to prove this through some of the numbers, hopefully, and then start to talk about on the tech side, really the innovation, some of the engineering, some of what we can bring to the table, and we'll try to keep it more technical, less marketing, try to help you out. And again, if you have questions throughout, you want us to dive into a section a little bit more, let us know, and we can focus on some of these other areas. But if we're looking from a numbers perspective, we have a hosting capacity currently in 21 live data centers of 1.3 million physical servers. That's massive. And we have 270,000 deployed and running today. Now across that, get into a little bit more, but I believe it's nearly 300,000 virtual machines. And now this is running on a backbone that is currently international, and that is providing an 11 terabit capacity globally. So we have 20, actually that number is from last year, 20 data centers, 5 countries, 4 continents. We're now up to 27, and we're moving very quickly towards 50 within the next few years. So big, growing, large presence. So again, those numbers to prove from this hyperscale capability, when we talk about that, we're really pointing to this growth, this strength, the breadth of what we have. And 1.2 million, again, live customers, 200,000 private cloud instances, and those are specifically SDDC stack instances. So this is vSphere as a service. So this is a game that we know, that we've been in, that we actually have a lot of history we'll touch on in just a minute here. Now alongside that, it's not just a vSphere cloud, it's also a public cloud, and we have dedicated server instances. So it's a combination of some of the other cloud providers that you've seen today. We have a little piece of each that we combine together to build a larger portfolio. And these exist in all of our data centers side by side. So with that, 500,000 public cloud instances. That is on an OpenStack-based service. To give you some of the benefits of a public cloud instance with some of the more instance individual server-based approach or VM-based approach rather than SDDC, which is giving you your own vSphere environment to then control how you want to provision your own VMs in a more rounded scenario.
Yeah, what you see with VMC on Amazon, right? You're really seeing kind of the blend of mode 1 and mode 2, right? Kind of DevOps with traditional operations. We've been doing that at OVH for some time now.
Now the company is still private, and it is owned by the initial founding family. They all have positions within it. Actually, you'll see Miro, who's in the very back there, walking around this conference. He owns part of our data center team, currently looking to launch new data centers globally and controlling that hardware and all those pieces that go into it. In front of him is going to be Octav. He is the initial founder and CEO, as well as their parents and the rest of their family that are part of the board in various areas of the company. So still very engineering driven, very family driven, more on that private mentality than some of the more public companies that are a little bit more board driven, perhaps. Biggest piece here to show off is the history. Now there is a lot of history. Again, it's a massive cloud with a long legacy. So going back to 1999, roughly around the time that VMware was founded as a company. But this started with Octav. He was playing around with some of the servers, started looking into hosting, and initially started hosting a small set of websites and services from a co-located location at the time. And then the family looked into it and then realized, well, why are we paying someone else for space when we could own our own data center and we could then cut some of the costs if we owned our own location. So they opened the first data center 2001. And then they started looking at, well, why are we buying servers from someone else when we could build our own servers? And we could save some of the money and the cost there, and that could allow us to be a little bit more efficient. So they started building their own servers from scratch. And we're not just talking about, buying a case from someone and then a motherboard from someone else and piecing it together. They have their own custom rack configuration in a container-based configuration. So they can drop in these low, sleek racks with 48 servers at a time that are custom designed and actually cut out of sheet metal. So they do all the sheet metal cutting custom. They cut their own dies for water cooling. They run their own lines for water cooling. They put this all together. They can drop it in with a forklift and just plug in power, your network, and your water. And that's it. And then they can scale out from there very quickly. And been doing that again for over a decade. Once I got the servers, now touching a little bit more on that water cooling, it was, well, why are we paying all this money for the air conditioning when water cooling is cheaper and it can be faster for us, a little bit more efficient? So we're going to start running that. And then moved further, well, we need to expand from the locations. Let's bring in more networking. If we own the network, we could do more with it. And then if we could bring in SDDC services, we could do more with that. And they've been running a vSphere-based cloud since 2009. So this is from ESX 4.0. So they have a legacy. We have a large customer base in a large area, but primarily in Europe. So this is a French-based company that is spread out within there. So if you don't currently have a European presence, that's where you likely haven't heard the name yet. So with that, let's look a little bit more on how they built it out. What are the technologies? What are the pieces you're really interested in? Not just that there's scale and there's a timeline and some history there, but what are some of the engineering innovations from the engineering company?
Yeah, what does all this mean? So originally, as I mentioned, this was titled, Why Does Optimizing Layer 0 Matter? Who knows what Layer 0 is? Perfect. Yeah, if you actually go out and look this term up on the internet, you'll see that they'll call this the cabling, right? But in a virtualized, cloud, abstracted world, what is cabling? You can have a physical server today that has absolutely no connectivity to the outside world, and it could have hundreds or even thousands of virtual networks, right? So what is layer 0? Well, it's the layer under layer 1, right? Yeah, exactly. My crack.
We were proud of this one.
What we really kind of thought about here was it's all the systems and all the components that it takes to create and enable physical and virtual networks, right? Like thinking about things that the way they were 10 years ago just simply doesn't work anymore, right? And what this really means to us, this starts with the buildings and the containers. So OVH is truly an engineering company. We actually have CAD designers on premise because when we go out, we're not trying to build the fanciest new building. We know that there's a lot of great buildings that exist out there. We just need to be able to retrofit it for our technology stack. So we are literally optimizing the buildings typically for cooling. Power and cooling is a very, very, very big deal because we're going to talk about why that really matters to you in a minute. Physical servers, networking, cabling, everything that it really takes to really enable a cloud, right? To get that packet from one side of the world to the next.
If you look at that top right too, that's one of the containers we're talking about. Yep. So not like a shipping container. This is a custom design, again, from the sheet metal pressing and from that large portion of the factory that we have. To being able to create this in the most efficient way and design to be able to drop it into these sites and then fit our custom racks into.
Yeah, as silly as it is, I asked, I said, how much do you build all these, every piece? They said, yes, we just don't bend the pipes. There has something to do with bending pipes, has to be very accurate, but they do everything else. So those containers were all designed by OVH engineers and built, and they are constantly optimizing. If you were to go over to our Gravelyns facility in France, you would see a Generation 1 container, and then you'd see a Generation 2 container. We are constantly reinventing ourselves to be able to squeeze out every penny, because ultimately that's one of the big...
If you notice that too, there's no raised floor. So with the design and the way that they've configured it, there's no raised floor. All the cabling goes up to the top of the container, and then from there we can take the water out and cool it from a radiator outside of the servers. So there is a little bit of airflow to keep that running through within the container, because of course there are still some air-cooled components, but for the processor mainly, that is water-cooled outside of the container, and then everything goes up for efficiency, and it's easy to take that out of the room wherever it is. And it also allows us, from what he was pointing on, to use existing buildings that are out there. One of our data centers that will be coming online soon in Virginia is based on an NSA surveillance facility that we have purchased and are retrofitting for a data center. We have one that currently in Roubaix it's roughly a 10-story office building. It looks like a normal office building, and it's the one that you might have seen in the video this morning they had a picture of. So it's a tall tower, not your standard low data center, because we can build in non-standard areas and use more efficient designs because of that. That we're not following some of the rest of the industry because we found a better way to do it.
And so what does this really mean? So when we think about like on the power and cooling side, so there's this idea, power usage effectiveness. So the goal is to be at 1, because if you see this total facility energy, right, this is the servers plus the air conditioning plus any other system that it takes, right, divided by the amount of energy it takes just to run the physical servers and switches. So the goal is to be as close to 1 as possible, right? So you can see here kind of a legacy data center 1.8, and we've seen numbers as high as 2 and 3, which means it takes 2 or 3 times, in this case 80% overhead, to operate the systems, the air conditioners, so that you can actually run the servers. Let's forget about like cooling. What does this really matter to you? This is about money, right? Ultimately, if we have to pay for those air conditioners, that's more expensive, right? If you can imagine, if we can operate our data center almost 50% more efficiently than somebody, that is big money. Air conditioning is not low cost. So if you look over here to the right, OVH has an overhead of roughly 9% because we don't actually have to use really any forced air cooling in most of our data centers. Mm-hmm. This is a big deal. So why does optimizing layer 0 matter? It really matters because ultimately you want to pay as low cost for a service as you can, and every one of those things that's done the old way, the way that it used to be, actually adds more cost. So does anybody in here heard the story of Roman concrete? Does anybody know about Roman concrete? Yep, one person. So truly, if you actually go to Rome, you'll see sites that still exist and still stand today. They optimized layer 0. They actually did concrete different than other people. So I used to work at Rackspace, hosting.com. We were basically taking off-the-shelf servers from Dell, EMC, and these types of folks. Well, there's a lot of overhead. You really are just buying, you're paying for all that margin every single time. You really don't have any money to innovate for customers, right? So the idea is, let's go to the lowest layer, right? The buildings, the containers, the physical servers, and let's make those efficient, and then everything else on top is much stronger. So layer 0, right? So you want to own the physical compute layer. And we don't mean you own the servers, we mean you want to own the supply chain. We mean when you're in a room with maybe a company, a school like MIT, and they say that they need a certain spec of NVMe kind of drives in the server, and we know what we have today, immediately the person who actually owns that build can say, we can launch with these next specs in less than X time, right? So by owning that, we can innovate on a much, much faster pace. We're doing the same things that the Amazons of the world are doing. It's in our DNA. We're not like kind of a more legacy hosting company, kind of like a Rackspace, where they're trying to retrofit, go back and change how they're doing. This is core. This is actually in our DNA.
Now, one note there too, full transparency, there are components that we don't own. So we purchase those at scale. We are, for example, a major Intel partner. as part of that. So the majority of our servers, of that 270,000 servers that we have deployed today, the vast majority of them are Intel based. So we are using mostly Intel spec machines.
Yep. On the network, again, you don't want to be reliant on other people for your problems. The more that you control, the more accountable that you can be ultimately to your customers. 32, go ahead.
As part of that too, our CEO, Octav, the global CEO, has a policy that he wants us to be fair to everyone. So currently we do not meter for usage of the backbone, for usage of our network anywhere. There's no in-out cost for just traffic, which it seemed crazy to him to be able to try to charge for normal usage of an environment like that. So
yeah, the goal really is, how many people like to pay tolls on toll roads? Do you like to pay tolls on toll roads? No, you do it for convenience when you have to, right? When it's a matter of kind of business. But for the most part, you want to drive on roads that you think are free. Like, let's be real honest. Nothing is ever free, but you're paying with those for taxes, so it's not extra money on top for you. So the idea, if you can make the network, if you can make the roads free, and we mean the roads from, Germany over to Canada, over to the US, that you're not paying for any more, like you are every time you egress on an edge, maybe in some of the 3-letter clouds, right? This is fundamentally different, and we're going to talk about that in some of the use cases as we move on as well. Yeah, minimize electrical costs. We covered this with the power usage effectiveness. This is just a big deal. This is really where rubber meets the road on costs. Minimize overall costs. We talked about this as well a little bit. Don't go out and build big fancy new buildings so you can take people on tours, make it work. In the end, most customers want it to be secure. They want to minimize risk. They want high performance, right? Those are kind of the 3 big attributes that they seek. And then lastly, what does all this really mean? So when you do this, it gives you the ability at the base layer, like our lowest level object in our stack would be a bare metal server, right? Because how many times do you actually go out and deploy a bare metal server in a cloud? You don't. You really can't do that actually. But why is it a big deal for us to say 120 seconds? It's not really that big of a deal, but let's say why it is. When you're building VMware clouds on top of it, when you're building OpenStack clouds on top of it, and you're talking about delivering an SDDC stack in 30 minutes. Did you see everybody watch the keynote this morning? Did you see the time that it talked about for an Amazon VMC on AWS deployment? 115 minutes, right? So we do this in 30 minutes. And to do it in 30 minutes, we need to be able to have access to those bare metal servers immediately, right? So every piece of this, even the bare metal environment, is controlled via API. Right? So this is fundamentally different from how other clouds are doing. And by starting at this lower level, you can build amazing things on top. So layer 1, right, in my layered approach, we own the network, right? So plan for this. When you don't actually own the fiber, sign very long leases, right? 25 plus years. Keep the fiber dark, right? You see the advances in technology. We continue to be able to push more throughput down the same pieces of fiber, right? Light is pretty amazing. And then make it global, right? As of today, or at the end of this year, 32 points of presence, 27.
Let's take a look at that.
Yep.
So to paint a clearer picture, this is a current live map. And the stars on there are going to be your vCloud Air data centers. So yes, vCloud Air powered by OVH, now part of the stack and part of the opportunity. They are alongside the other OVH data centers, and where those aren't riding the backbone today, they will be soon.
Yeah, so imagine that you can go from Oregon all the way to Tokyo. Imagine you're paying for an MPLS circuit today, right, to create your own backbone. So some of the use cases, and we'll get into more detail on this, but this idea of kind of telco augmentation, being able to potentially replace a portion of your backbone with a cloud provider. That's kind of crazy. It's really unique.
And some of those numbers too, it's a little fuzzy, but you can see that yes, these are high-speed lines running between multiple locations. And since portions of these are still dark, there's an opportunity to turn up more and enable more speed and bandwidth in the future.
Yep, exactly. So layer 2 and layer 3, for me, this is when it really starts to get interesting. The networking portion. When we go past this as a great technology and we want to really move into implementation and we start talking about how you're going to connect from on-premise to the cloud, right? We really start to talk about layer 2, layer 3 connectivity. Now in vCloud Air, if you have worked with us, we only did, it was called Direct Connect in vCloud Air, and this happened at layer 3. With OVH, we have the ability to connect you at layer 2. This is actually called vRack Connect. But what is, so global layer 2 adjacency, so the technology we call this is vRack. The name vRack, what does it mean? It means that you can have a server in Canada. It means that you can have a server in Tokyo, in the west coast of the United States, and those will be on the same layer 2 network. So the idea is you're truly creating a virtual rack, and not only in the same service, like have a VMware cloud, but if you wanted to connect an OpenStack instance, let's say your operations folks are very, very knowledgeable with vSphere, right? But your front-end web development team, they're taking advantage of OpenStack. Right? And let's say for licensing and performance reasons, you still want to run your database on bare metal servers. Right? Wouldn't it be great if no matter where those servers were in the globe, if you needed it, network engineers might scream a little bit at the idea of layer 2 adjacency globally for obvious reasons, but when you need it, right? Hard-coded IPs, when you really think about how hard it is to move from on-prem to the cloud, this is a very, very, very big deal. And this is in hardware, right? So this first line is really about talking about what we do in hardware. Every customer has the ability to have 4,000 VLANs. In vCloud Air, in one of our data centers, we had 4,000 VLANs. So every single customer has the full breadth of VLANs.
And it is customer controlled through a portion of the UI because everything, and we'll get to this a little bit later, is automated. A very heavy automation that we've been running for nearly a decade now and working on.
Yep. And if you take we have the possibility for 64 billion interconnected global customer network segments, right? This is a combination of VXLAN and Q&Q. And this is what we're talking about just at the hardware layer. Things get even crazier when you actually talk about going into NSX and being able to do VXLAN inside of NSX, right? So this is truly some unique capabilities on the networking side. The network is extremely strategic for OVH. On the software side, at VMware, everything was about software primarily, right? Making the most out of hardware really took software. That was the stance, right? So we still have the best of VMware's technology. We're currently still the only provider that has access to what's called
Hybrid Cloud Manager.
HCM is a hybrid cloud manager. This gave us the ability to do layer 2 stretch from on-prem to the cloud. It was the fundamental piece that allowed us to do no downtime, vMotion-esque migrations to the cloud, right?
But even more than that, it's doing those without vSphere 6 and above. Yeah. So if you have 5.5, we can, in no NSX, we can still do a layer 2 extension, and we can do a vMotion-based migration. You don't have to have linked mode. You don't have to have the newest and greatest installed. We can work from your legacy to help you get it into cloud. And that's what the current version, one that will be released soon in the future, will allow even greater compatibility back to 5.1.
Yeah, so we get the best of both worlds. If you have paid attention to the Cisco and VMware fight, like a little bitty tiff right between NSX, OTV ACI, those types of things, what you really heard people say is if you can afford it, it's better together, right? The best of the best hardware, the best of the best software together is magic. That's what we have, right? We're doing things in hardware that make sense in hardware. We're doing things in software that make sense in software. And we have the capability, this is kind of more of the detail, but we can either do very high throughput layer 2 concentrators above 3 gigabits per second for a few number of VLANs, or we can actually do lower throughput for a very high number of VLANs.
And that's talking about from on-prem to cloud, potentially across a public line. No, private, of course, is going to be a little faster.
Yeah, I talked about this first, but vRack Connect, this is what we, in vCloud Air, we call Direct Connect. This is the ability to extend your network from on-premise to the cloud and do this at layer 2. We couldn't do this in vCloud Air. We only had our VLAN space across the data center, and we were concerned with customers creating loops on our behalf, right? So everything that we did was at layer 3. So now you have the flexibility of doing this at layer 2 or at layer 3. Many of our customers wanted to do it at layer 2, the more advanced ones. And then, of course, we still get the best out of NSX. I was at a meeting once, and the VMware rep came out, and she said, I said, okay, what did you think? And she said, what I heard is I don't need NSX anymore. And I'm like, wow, no, I'm so sorry. That is absolutely not the case. There's the time for doing things in hardware, and there's the times for doing things in software, right? Distributed firewall, microsegmentation, maybe let's move away from what Cisco kind of says about this, but you can't do those like you can, right, in software on top of the stack. So this is where NSX distributed firewall capabilities at layer 2, the ability to click one button and stop all traffic at layer 2 across the data center.
Now, this is something too that's available both in vCloud Air today and in the OVH data centers, and of course it'll be available in both going forward too.
Absolutely. And this is just a little bit of detail around vRack. For me, this is one of the truly innovative and unique things that I've seen a cloud do. It's very hard to get layer 2 adjacency in other clouds. It really is.
And this is part of the service that's included with the hosted private cloud instances. Yeah,
that's a very good point. Costs are built in. So I don't like the term free because you're paying for something. Anytime somebody says they're giving you something for free, they're lying to you. But they are bundled into the costs. Right? The idea of being able to leverage this global network, it is bundled into the cost that you're going to see from us later this year. So layer 3. So I mentioned it before. We could do this in vCloud Air. So we have the ability to do direct connect at layer 3 if you so choose. We still have the best advantages from VMware technology, leveraging distributed logical routing, and all of the advanced routing capabilities that exist inside of NSX, all are available in our cloud. And one that's really interesting, anti-DDoS. So we have a technology, we call it the VAC. It kind of makes sense, it kind of works, it's got the vacuum. Does everybody remember the IoT camera attack last year that took out Dyn? Raise your hands, people remember that attack, right? That was kind of a big deal. Well, they also launched that attack at OVH. I think it was somewhere between 700 megabits per second and a terabit per second, somewhere in that range. And we effectively mitigated that attack. Ask Dyn how they fared.
We didn't, not a single website went down.
Yeah, not a single website went down. And unfortunately, much of the East Coast actually went down because people could no longer resolve host names on that side of the world, which actually affected a lot of other three-letter cloud companies.
And that was with the previous revision of this. We're up over 3 terabit a second processing capability on this today. So what you're looking at, on the top line, traffic's going to flow normally from our backbone to our data center router. And if we start to detect a sharp uprise in traffic, we can start to inspect the packets and see if it is the potential from a given multiple sources to the same thing in a way that we would identify as a DDoS attack. If that's the case, then we would push it then through our VAC to go through multiple levels of the firewall to then look even further into the traffic to make sure that we're making an intelligent decision on that. Now again, we're not reading your data. We're looking more into source, destination, behavior across multiple sources within the given period of time. So we're gonna take a little bit closer look at what that is to then bring it through, filter out what is the bad traffic, and then bring it back up through the data center router and into the site. This is all automated, it's part of the service, it is turned on by default. And there are 2 other options. So if you don't want that automated discovery, you can either turn it off then and always go through the backbone straight to the data center and ignore the anti-DDoS, or you can turn it on all the time if you want everything to go through the VAC for all traffic. Now, of course, there is a little bit of a latency hit because we're going to make a few more hops, and we're going to treat the traffic in just a slightly different way to be able to look at it again and do some anomaly detection with it. But otherwise, it'll still make it to your servers in the way that you need to. So you have flexibility to control how you want this to work with your given environments within the service, and that is included as part of the service.
Yeah, and from an architecture perspective, these are distributed across the globe. So when we talk about vacuuming, reroute traffic, we basically use BGP to distribute those to the data centers that have our VACs. Right? I think we have 3 VACs deployed right now, roughly a terabit per second of capacity. So we actually do automated BGP injection so that we reroute traffic, so that we distribute it so that we can handle it. Because if we only had one location, it would be possible to potentially take that out. So being able to take advantage of BGP and completely automate this is another big deal. So as Neil mentioned, 3 terabits per second right now of anti-DDoS capacity.
And
I haven't seen an attack bigger than 1.
No.
So I mean, from a risk, right? I really do believe that making buying decisions in cloud, risk, costs, and performance are very big. And risk is when you get into very, very large deals, C-level and every executives are involved, they really start to care about risk, brand reputation, right? They can't get those things back. This is a big deal. You can't be offline today. These are the types of technologies that keep you online. So layer 4 through 7, these are just going to be a few more interesting things across our stack. So I mentioned Hybrid Cloud Manager. This is effectively an SD-WAN solution. So when you deploy Hybrid Cloud Manager, you synchronously deploy 3 pairs of virtual machines on-premise and in the cloud. Right? Layer 2 concentrator, so that you could do a layer 2 stretch from on-premise to the cloud, a cloud gateway, and then also a WAN optimization appliance. And so all traffic that goes across the wire that's for disaster recovery, for low downtime migration, this would be a replication-based migration where the VM is turned off at the very end to do the last sync and then powered up on the overside. And also our no downtime vMotion type migrations. So literally only dropping a single packet as you move a VM from on-premise to the cloud, retaining same IP, same MAC, all of those things. Global network capacity and performance visibility. So it's really nice to see that, that really static picture of what our throughput actually is across the globe. But what if you have a problem, right? What if you're just curious, how is this network actually set up? Typically, somebody's going to make you go under NDA for something like that, and then they're going to tell you about these types of things. This is not the way OVH works. We say innovation is freedom, information is freedom as well. So you can go online and see pretty much, minus IPs, you can see our reference architecture. You can see the architecture between our data centers and our data centers, and you can see the capacity of every single link in real time. Right? So if you knew that there was a problem, typically you start to call people because you have no visibility into these systems of the provider. Right? It's a big black box, effectively. Right? So starting all the way down to kind of layer 0, right? We're going to go all the way down. So with network capacity, and then also our servers. So the same thing that we do with the network, we do for servers. So every one of our data centers, you could click in, and you can actually correlate with the name of your server to where exactly your server is in our data center. And you can see if there's any data centers down in your pod, effectively. Right? So if you log in and, oh yeah, wow, look, there's this, looks like this whole container is kind of down, right? You have that level of visibility.
Now, beyond that, we do have performance visibility for your individual environment as well. So if you're running a hosted private cloud, that's going to be that SDDC stack, then you're going to, by default, get, at least in Europe today, you're going to get vScope. It's a bit of a dashboard that we built to monitor some of the base performance. Think of it as a super lightweight version of VROPS. But then VROPS, of course, as a service is also part of this and part of the stack that would be provided as an add-on if customers want it, if they want to add that extra visibility and that piece pre-configured and ready to go.
Absolutely. And so we are not just infrastructure. People heard of the term kind of mode 2 from Gartner, right? The kind of the legacy systems, client server, kind of mode 1, and then mode 2 being cloud native apps, right? Kind of next generation applications. So you will start to see from OVH Group, they already have a number of these services already productized. Container as a service, right? If you think of the OpenStack cloud, that's kind of the lowest entry point to really saying you have a DevOps enabled cloud, and then next you really want PaaS type components built on top of it, right? So all of our service status availability is online for all services globally. And then finely tuned automated deployment. To be able to deliver the promises that we're making on delivering SDDC in roughly four times less than what they're doing on top of Amazon today, you have to have every single thing automated. And also secure. So we don't talk about this quite as much in here, but all of our environments, OVH Group today, are PCI compliant. When I was at VMware, I asked, I'm going to mess up her name, but on the keynote, Purnami, I apologize. I was at the CTO conference for VMware, and I went up, I said, is compliance a first-class citizen yet inside of the BUs? I said, or are these just security features that you're being asked to implement without really the context of compliance? And she said, no, these are just features. I didn't know what answer I was expecting. I don't know when you say, is compliance a first-class object in product, what that answer was going to be. And then when I went to Dallas and met the OVH team, a question came from one of the DevOps engineers. And he said, well, what type of challenges do you have when you go to launch these new robots that automate your infrastructure? And the answer from Francois was I got chills, it was good. He said, well, remember, we're PCI compliant across our entire infrastructure. So we have to do code reviews. So basically his answer started with compliance. When you think about like where is risk in an organization, right? That's at the lowest level. That's at the person who's building the processes for the engineers who launched this software on top of our cloud.
Well, and then let's talk about some of the features of the automation. So today in the vSphere stack, you have an HA event. One of your hosts goes down within the cluster. We're going to automatically detect it. HA is going to kick in, of course. It's going to evacuate the VMs or bring them up as soon as it can on another host. But we're going to take, once it's completely clear, we're going to take that old host out of the cluster, we'll add a new one in, and we'll do that all automated in less than 10 minutes. So you will have a new host in the cluster, we'll take the other one aside, we'll do a full root cause analysis on it, figure out what went wrong, and then we'll contact you and talk to you about what went wrong, what that looks like, and whether or not, if we fix it, or if we can fix it, you would like that host back. But I don't think we've had a single customer say that they wanted the old host back afterwards. But automated catch of an issue and a piece of automated HA there. And that's on top of, and really built alongside, our automated deployments of our dedicated server, the PCI, our public cloud stack, as well as this hosted private stack. So everything is automated. The VRAC piece is automated and controlled from the user. Everything is built around our custom automation.
Yeah, this is truly a part of the DNA at OVH. So Neil?
All right, so let's talk a little bit. We have some features built from the ground up, a little bit about those stacks focused on our hosted private cloud on the left-hand side. But let's build a little bit bigger picture here. So we have three main product lines. Hosted private cloud, of course, is going to be that main one, and that's why you're at the event. You're looking for vSphere-based clouds because that's what you're running on-prem or what you're interested in. Now, we run this alongside, as we mentioned earlier, an OpenStack-based cloud, and that's going to be that public side, very instance and size-based per VM, more on an hourly basis, versus our dedicated servers, which are then going to really open up more use cases on the side. And this is our oldest stack. We've been doing dedicated servers longer than anything else. And with those dedicated servers, we will provision that again in an automated way, give you access to it. And we have a catalog of images available, or we can connect back on-prem so you can provide an image too. And this allows you to piece together services as you need. So you can use your hosted private cloud for your standard VMware-based workloads. You can then VRAC that to an environment for your public cloud instances for some DevOps projects. And that public cloud is going to have more of that DevOps moving towards the mode 2 possibilities. And then alongside that, you have your dedicated servers for some of your legacy or your high performance. That's going to be your GPU-based compute. If you need that, it's going to be your Oracle-based workloads from a licensing perspective and a performance perspective. Anything that you want to have that full control over. It can even be a VMware-based environment if you want to control the entire stack and simply lease the hardware for it. Now that is built over that fiber optic network, again with that 11 terabit per second, the anti-DDoS, the VRAC and the private LAN capabilities on it. We have, so of course, global support with it, and we now have global reach that is growing exponentially. Now it's starting to get faster and faster as we release more and more data centers, more and more POPs. So with those use cases, what we're traditionally seeing from our customers, of course, there's the top three. And we've been talking about this with vCloud Air for a few years now. The three main, and you'll hear it honestly across most cloud providers, and especially the vSphere-based ones, or VMware Cloud Provider Program, as it's now being called, used to be vCAN. But we are a cloud provider program member. We're a certified cloud provider from VMware, and we're going to be offering this in a similar line to some of the other cloud providers, but focus really on data center extension, that idea that you have something on-prem and you just need to grow. You need a bit of burst capacity. You need something faster than you could get it ordered through a hardware vendor, rack stacked and put on-prem. Plus this shifts it over to OpEx versus CapEx. Or you want a full data center migration or data center replacement. You want to shut down an old data center legacy equipment, get off of that. You need resources to be able to do that on. We can set up a cloud side by side. We can do that layer 2 adjacency. We can vMotion your VMs over with no downtime. Then you can shut down your old data center when you're ready. And then you can spread out your services, again, combining those three product lines to be able to meet the needs where you have them. We also then have disaster recovery, of course, that's going to be completed through a few ways. So we do have dedicated disaster recovery-based clouds, either using vSphere replication as the primary software for it, or we have HCM to provide a more scalable method, which is going to give you some WAN-op in between some of that replication, give you the layer 2 to that older environment. So again, from vSphere 5.5, if you don't want to have that private line and bring something else in, to get the layer 2, we'll do it from a software level, from on-prem, from your older instance, and we can do that with continuous replication for your DR VMs and multiple point-in-time copies. And then of course, we also have Zerto as part of the global catalog as a more agnostic solution to be able to provide lower RPOs for customers, but also provide some of that agnostic capability between hypervisors so that you could fail over Hyper-V VMs into a vSphere-based environment.
And something else to notice on disaster recovery, a lot of times you're really stuck in either a complete failover scenario, right? Because you want to maintain the same IPs on the other side, but you don't have that layer 2 adjacency. So that means you have to do a full failover. You couldn't just fail over one component. Like where you had a database server that was going bad and you're like, ooh, wow, I really wish I could fix the hardware that this database server is on and actually just fail over just my DB server or just a single component of the app stack to the cloud because you didn't have that layer 2 adjacency. So we easily handle full site failover, and then with this layer 2 adjacency on top, you get the ability for partial failover as well.
Yeah, think about that. If you have 2 different subnets and 2 different sites, and that's your sort of failover path, then yes, you can fail over one at a time, but then you have to make all of those IP changes, everything else, change your load balancing, do a lot more configuration to bring it up. You are slowing down your time to recovery. But if you can have a layer 2 adjacency between sites, you can bring up one, it will shut it down on-prem, you recover it in the cloud immediately. Just it looks like a reboot, and then you have that other running copy, and it can still connect to everything back on-prem, which could be useful if, yeah, you have a single server failing. When I was back doing IT consulting about 8-9 years ago, working for a government entity, and at the time, a geological survey, and they had a pipe break atop of one rack. So they had a networking closet, a few servers in there, and it took out one rack. It was a stream straight down over the hardware and then out of the room. Other racks were fine. They were able to continue running. The power source was fine with the way they had it cabled, but one rack was down. So in a situation like that, they wouldn't be able to fail over just one rack unless you had that layer 2 adjacency. So we do have ways to be able to provide that for partial failover of an environment, for easier configuration of the environment to go along with it.
Yeah, and so some of the new possibilities, and these are the things that got me excited when I came to OVH, when I got to hear the story about the backbone and the fact that we don't kind of nickel and dime you as you're kind of writing that. So I was recently in London because a very large marketing company was, they're international, I mean billions and billions of dollars, but they were very interested in this idea that if they could just last mile to the cloud, they could use the cloud effectively to replace a significant portion of their MPLS backbone. So that doesn't exist. There is no cloud provider that has that capability today. So really when you think about these things, many times cloud kind of starts at like the VM or higher. That's not the way that it works for us, right? It literally starts at the lowest layers possible. And so telco augmentation is what I've been kind of calling this. Anybody in here use Ariaka? Okay, good to know. There's some interesting technology out there that can use some software components that can actually get you into, so Ariaka actually does a kind of an SD-WAN stack and allows you to get into their backbone, and then they'll help off-ramp you to other places. Well, when I looked at this, they were basically, their story is MPLS replacement. I've been calling it telco augmentation. The same idea, but this is from a cloud provider. This is not an individual software vendor. This is someone who can not only provide network capability on a very advanced level, but the infrastructure that you need as well, kind of full stack. And then last, hardware. So MIT is an example. I worked the MIT story. You probably heard that one a couple times. They're migrating all of their enterprise IT workloads to the cloud because of the compatibility, so that they could keep HPC, high performance compute on premise, right? At the time, for the highest performance compute, right, for those big clusters, you really need bare metal capability, right? And that's just what we hear. Well, not many clouds do bare metal, right? Very few actually offer straight bare metal servers. So with us, you could actually orchestrate an HPC cluster on top of bare metal in our cloud. I affectionately call it bare metal cloud. I don't know if that's the term that will be used, but API controllable, available in as little as 120 seconds. If you see on our site 120S, that means you'll have it in 120 seconds, the bare metal server, with KVM over IP access to install your own ISO or to leverage one of the 90 operating systems that we have. So these are truly unique things that should all open up the possibilities, even if you're waiting on hardware from Dell, right? Michael believes that people are going to come back to the cloud. They're going to go to the cloud is expensive, and they're going to come back. This is a different cloud. Right? We don't nickel and dime you. That's what most people are upset about with Amazon. It's those nickel and dime charges, right? And then why are you coming back on premise? For control and visibility. What if you got control and visibility in a cloud all the way down to the bare metal server?
Now with that, it's fairly simple. We can build this out. So with those bare metal hosts, you can combine that with the other services, and we'll have that split between either private networks across the backbone or reaching out publicly to get to your other services. And we can start to get larger and larger with that. We have, of course, our hosted private cloud, and what I want to point out here and a bit of the design and what that looks like, we're going to build your cluster out. We're going to give you storage, primarily NFS based, and then we're going to move all of the management servers for that out of that cluster so that you get 100% of the resources. And in fact, we're going to start that with what we call a pack. You get 2 hosts to begin, so it's the lowest entry point for a cluster. Of course, you have 2. And then on that, we'll give you a low entry point of storage, and then you can buy up to larger versions. If you want to connect that in, we can do up to 70 NFS data stores per cluster to build that out. In the offering that we're planning for the US, that's going to give you over 2 petabytes per cluster. And you can mix and match hosts in that cluster as you want to grow it in the way that you want to grow. And again, you're going to get all those resources because your VROPS, your NSX manager, your VCSA, all of that, your other management systems, all of those are going to sit outside of your cluster in an area that we manage. So then we can do our management of the upgrades and the other pieces, and we give you majority access to the resources and the rest of the environment. And we can start to then connect that into larger and larger pieces, bringing in either direct connect lines if you want that, or that VRAC connect for the dedicated fiber to then one of our 32 POPs globally, ride that network, come into the environment. Or we can use that to then mix and match with other services too. So you can do a bit of your bare metal from those low end, I believe they're around 6 core machines, so very basic low starting point for basic services up through our high end HA clusters, through our game servers, which are more frequency heavy. So it's going to be that over 4 gigahertz for some of the gaming applications. We have GPU based services. So we can mix and match for your physical needs. We then do these are the acronyms. So PCC is going to be your private cloud compute. That's going to be that vSphere based environment versus PCI, which is going to be your public cloud instance. Those acronyms are based on the French translations. So we do get some confusion on that sometimes, but yes, you can mix and match, do this all together, build out these larger use cases of multiple services across global data centers. And that is in every region. So North America, your EMEA region, and then APAC, of course. So then bringing this full circle back to the beginning, we aim for performance from that ground up when we're building this. A big part of that is owning the servers as much as possible, owning that low-level network between everything, automating it where we can to do performance of not just delivery, but then of the HA and the other capabilities with it. We're an engineering-based company, so as part of our optimization, of course, adding in those extra services that we see a need for, and we're providing as part of the package, so that anti-DDoS, of course, or that VRAC solution. And then not metering for traffic. There are going to be throughput caps for the different types of environments, but you're typically looking somewhere around a gig to start, and then you can up the throughput for that, but we're not charging for anything beyond there. It's just making sure we can share the network a bit between users and not over allocate what we have. So leading back to our first point, we're a global hyperscale provider. I hope this was a good intro, a bit of the piece, more of the history, and some of the technologies and the things that make this unique, and things that I hope you're going to be asking your data center or cloud providers for. We are a service provider. We're one of 4,000 service providers globally, and we're one that you're going to start seeing the name for a whole lot more. And we really differentiate just by vertically integrating, owning as much as possible. And then more on an engineering mindset, which is part of where you're starting to hear the name now, because we're not a marketing company. We are an engineering company.
Good and bad with that, right? That's the piece. Who is OVH? You don't know? That's not good, right? But the idea is, originally what they would tell you is that people bought services from OVH. They built really great technology. They put it on their website. People organically found it and then consumed it. But they started to develop technology beyond that kind of customer base. Things like VRAC, some of these other advanced technologies, those don't really fit if you're selling just 20 to 500 euro servers, right? So now we're coming around and we're basically letting the world know about this technology stack.
So of course, we'll be hanging around here for the next 10 minutes and a little bit beyond the session as needed. If you have any questions, want a little bit more information, whatever it would be. But you can reach out to us if you want through the social media channels. We also have a booth that I'm sure you haven't been able to miss right at the front of the Solutions Exchange. And of course, the new US website that is recently launched there. We do have a number of other sessions too if you are interested in learning a little bit more of some of the lower level technical designs, architectures, situations, things that we can do here. We have a few more this week, still aiming for either later today or on Wednesday. And with that, of course, a reminder to please fill out the survey. Love to learn a little bit more about what we can do to better meet expectations there.
Did we teach you anything new today about OVH? Did everybody learn like one thing? Raise a hands. One thing at least. Okay.
Okay.
Yeah, you got an
something
excuse,
useful,
man.
hopefully. Yeah. All right. With that, we do have a microphone in the center. If there are any questions, you want a little bit more detail, and we're lucky
Otherwise,
enough.
we're here.
Yeah.
Very informal. Thank you all very much. Appreciate it.
Thank you.